Hello everyone. We are a group of dedicated students working collaboratively on the project titled Logistic Regression using Titanic analysis. This project explores the application of logistic regression in predicting survival outcomes based on passenger data from the Titanic dataset. Our group consists of the following members: myself Riddhi, Kaustubh, Janyabi, and Siddhi. Together, we have contributed to data pre-processing, model building, analysis, and interpretation of results. Through effective teamwork and mutual support, we aim to demonstrate a clear understanding of logistic regression and its practical application in data science. So, today I'll be walking through a data pre-processing and visualizing analysis on the famous Titanic dataset. So we have extracted our dataset from Kaggle. So here is test.csv file and train.csv file which we are training. So we will use Python libraries like pandas, NumPy, matplotlib, and seaborn to clean, explore, and prepare the data for modeling. Now let's get started. So here in the first code, we have imported NumPy as NP, pandas as PD, matplotlib.pyplot as PLT, and seaborn as SNS. So NumPy and pandas are for data manipulation, matplotlib and seaborn for plotting and visualization. Now the next code here is test_df is equals to pd.read.csv. So here we are reading our test file, and in the next code we are reading our trained file that we have trained. Now train_df we have used to see our data. So we are loading here the training and test data using pd.read_csv. Our focus here is on the training set. Next, exploring age distribution. Like here we have used the code ax is equals to train.df age and hist. So here in this code, we are plotting a histogram and a destiny curve of the age column to understand its distribution. The green histogram shows how ages are spread, while the black curve gives us a smooth estimate of the distribution. In the next code, is null.sum. So here we are checking for the missing data. Okay, now we find that age, cabin, and embark have missing data. We'll deal with these in next. Now the next code is print train_df embarked value counts, SNS count plot, and so on. So here we are plotting the value counts of embarked, and this shows the frequency of embarkation ports. Most passenger embarked from S. So here S is the count plot visualizes this, which help when we fill missing values.
My name is Kaustubh and now we will be discussing about handling missing values. Train data equals to train df copy. In this code we have discussed about we copy the data for manipulation, then we will fill missing age values using the median, which is robust to outliers. For embarked we use the most frequent value, which is S. Now we have before versus after filling age. Ax equals to train df age dot hist bins equals to 15, density equals to true color red, comma alpha equals to 0.5 till ax dot legend age before, comma age after. In this we copy. In this graph compares the age distribution before and after filling missing values. You can see the yellow and green representing the new values. You can see the yellow and green representing the new values. The shapes remain similar, confirming the median imputation was appropriate. Now we will discuss further about encoding categorical variables. Train data equals to pd.get dummies train data, comma columns equals to sex, comma embarked. Here we use one hot encoding to convert categorical columns like sex and embarked into numeric form. This is necessary for machine learning nodes. And finally we are talking about dropping irrelevant columns like train data dot drop passenger id x is equals to 1 employees equals to true till train data dot drop ticket x is equals to 1 employees equals to true. And thus we remove columns that won't help with modeling name ticket and passenger id, don't provide useful numerical insights.
This side is Jahnavi and I'll explain the further code. Train underscore data sex female equals to np dot where train data sex female equals to true, 1 or 0. Here we ensure all boolean columns are converted to 0 and 1 explicitly using numpy's np.where function and sns dot kd plot train data age train data p class equals to 1 color equals to green and fill true. We use KDA plots to compare age distributions by class. First class passengers tend to be older than those in third class, which suggests socioeconomic status may influence survival. And SNS.KD plot train underscore data fare train underscore data p class equals to 1, color equals to green and fail equals to true. Similarly, this shows fare distributions by class. Fares are clearly higher in first class as expected. And SNS dot bar plot x equals to p class, y equals to age, data equals to train underscore data, SNS dot bar plot equals x equals to sex, y equals to p class, data equals to train underscore df. SNS bar plot x equals to parch, y equal to p class, data equals to train underscore df. These bar plots shows how age, sex and female size vary by class. For example, more men in third class and passengers, while more parents and children tend to be in lower classes.
So now I'll explain further. It is basically feature engineering, as we can see the code here, that is train data travel alone is equal to np.where till train data dot drop parch access is equal to 1 in place is equal to 1. So in this we have basically created a new feature that is travel alone, that if a passenger had no sibling, spouse or parents or children abroad, so we label them as alone. We then drop the original columns since they are not combined, as we can see in this bar plot easily. Second is that SNS dot bar plot x is equal to travel alone, y is equal to p class, data is equal to train data. So in this we have basically plotted, like our plot shows how class relates to whether someone traveled alone, and a large number of solo travelers, as we can see in this bar plot easily, that solo travelers were in third class mostly, like 2.51, the p class. Now the last is that sns dot heat map train data dot core and not is equal to true. So it basically says that finally we use a heat map to check correlation between numeric features, like we have seen here through survived, sex female, sex male, embarked c, embarked q, embarked s, and all this. So in this this helps us understand what features might influence survival and guide future modeling steps. So in conclusion we can say that, to summarize, so we have basically cleaned the data set, handled missing values, encoded the categorical features, engineered a new variable, and visualized patterns in the data. And with this our data is now ready for machine learning modeling such as logistic regression or decision trees. And like this, from this we can say that this is basically our code. And thanks.